Here's a series of comments on Nash equilibria and simultaneous games. If the strategy for a row or column is always the best strategy, that strategy strongly dominates all other strategies. If all players have a dominant strategy, then the Nash equilibrium is for each player to choose the dominant strategy. If the strategy for a row or column is either the best strategy or tied for best, that strategy weakly dominates all other strategies. The example we did at first with the Time and Newsweek is an example of strategies that dominate all other strategies. In the first game, no matter what Time did, Newsweek's best strategy was to choose Angelina Jolie. And no matter what Newsweek chose, Time's best strategy was always to choose Angelina. Therefore, the Nash equilibrium was for Time to choose its dominant strategy and Newsweek to choose its dominant strategy. An equilibrium can be strong or weak or mixed. An equilibrium is strong when defection always hurts the defector. The examples we did earlier of Time and Newsweek were strong equilibrium. Either player would be hurt if they did something different than the Nash equilibrium choice, given the other player chose its Nash equilibrium choice. An equilibrium is weak when defection may result in the same payoff for the defector. That is, I can't make myself any better off given what the other person's done, but I might be just as well off if I deviate from the Nash equilibrium. An equilibrium is mixed when the players choose probabilities for actions, not actions. Mixed equilibriums occur when no cell has both payoffs circled. All mixed equilibriums are weak equilibrium. Number 3, finding Nash equilibrium from mixed equilibrium. Finding Nash equilibrium from mixed equilibrium requires knowing the exact payoffs for all players. But finding Nash equilibrium for equilibrium that are not mixed requires only that the players know the relative payoffs. This last point can be very helpful. We don't have to know the exact payoffs to find Nash equilibrium in many games. All we've got to do is know whether the payoffs are higher or lower than others. A game can have more than one Nash equilibrium. When they have more than one, we have some idea of which one is more likely to occur. Strong equilibrium occur more frequently than weak equilibrium. Pareto-efficient equilibria occur more frequently than equilibrium that are not. An equilibrium is Pareto-efficient if all players have higher payoffs there than in the other Nash equilibriums. The third point is that, let's make this its own thing, but another point is that Nash equilibrium often appear to be stupid because it fails to maximize the total profit for the two firms. And the final point is a little fuzzy, but maybe the most important thing in this whole lesson is shape the game to your advantage. A slight change in the game may increase the equilibrium payoff to a player, even if the change appears to hurt the player. Share if doing so helps you, and the government can be your ally. We'll work through some examples of this in the Expand Your Understanding questions that we go through in class. We'll take a break now and pick up the next lecture in a little bit.